Have you ever gazed up at the night sky and wondered, could humans ever reach those distant stars? Welcome to the captivating realm of interstellar travel, a concept that transcends the boundaries of our imagination and challenges the frontiers of human ingenuity. It is the idea of humans venturing beyond the confines of our own solar system, reaching out to the myriad of stars that sprinkle the vast cosmic ocean. The notion of interstellar travel is not just an exploration of space, but also of time. It's about embarking on a journey that could last multiple human lifetimes. The distances involved are mind-boggling. Our closest stellar neighbor, Proxima Centauri, is about 4.25 light-years away. In layman's terms, that's approximately 25 trillion miles. Even if we were to travel at the speed of our fastest spacecraft, it would take us more than 70,000 years to get there. Today, our space travel technology is still in its infancy. We've barely taken our first steps, having ventured only as far as the moon, a mere 250,000 miles away. The Voyager probes, our farthest emissaries, are just now reaching the outer limits of our solar system after more than 4 decades of travel. The challenges are immense, but so too are the possibilities. The advancement of technology accelerates with each passing year. Concepts once confined to the realm of science fiction, like warp drives and wormholes, are now being seriously considered by physicists and engineers. Yet the reality of interstellar travel is more than just overcoming technical hurdles. It's about redefining our place in the cosmos, challenging our perceptions of what is possible, and daring to dream on a truly cosmic scale. So the question remains, how can we possibly traverse such immense distances? In the following scenes, we will delve into the fascinating concepts and potential technologies that might one day allow us to reach the stars and become a truly interstellar species. To understand the challenge of interstellar travel, we first need to grasp the concept of light speed. So what exactly is light speed? It's the speed at which light travels in a vacuum, and it clocks in at an astounding 186,000 miles per second. That's so fast that light could travel around Earth 7.5 times in just 1 second. Now, why is light speed so significant in space travel? Well, it's currently the universal speed limit. Nothing in our known universe can travel faster than light, according to Einstein's theory of relativity. This speed limit poses a considerable hurdle for interstellar travel. Let's say we wanted to visit our nearest neighboring star, Proxima Centauri, which is about 4.2 light-years away. Even at light speed, it would take us over 4 years to get there. But what if we could reach or exceed light speed? Wouldn't that solve our problems? The answer is not as straightforward as you might think. As we approach the speed of light, some pretty weird things start to happen. Time slows down relative to an observer at rest, a phenomenon known as time dilation. And if we could somehow reach or exceed the speed of light, time would theoretically stop or even reverse. Moreover, reaching such speeds would require an astronomical amount of energy. To accelerate a spaceship to the speed of light, we would need more energy than currently exists in the known universe. Not to mention, the ship and its passengers would be subject to extreme forces that could rip everything apart. In addition, there's the issue of cosmic radiation. At such high speeds, even tiny particles could strike the spaceship with the force of a nuclear explosion. This risk makes light-speed travel dangerous and potentially deadly. As you can see, reaching or surpassing the speed of light presents some formidable barriers. But don't lose hope. In the next scene, we'll explore some intriguing concepts and potential technologies that might one day allow us to overcome these challenges and journey to the stars. If we can't break the speed limit, could we cheat it? Let's delve into time dilation and wormholes. Now, one of the most mind-bending outcomes of Einstein's theory of relativity is the concept of time dilation. In simple terms, time dilation describes how time runs slower for an object in motion compared to one at rest. Imagine you're on a spaceship traveling near the speed of light. According to Einstein, you would experience time at a slower rate than someone back on Earth. To you, the journey might feel like a few years, but back on Earth, centuries could have passed. This is the magic and the curse of time dilation. But what if we could sidestep this issue? Enter wormholes, theoretical shortcuts through the fabric of space-time. Wormholes could potentially offer a way to traverse vast cosmic distances in a fraction of the time. Imagine folding a piece of paper in half, with one point representing Earth and the other our destination. A wormhole would be like a tunnel connecting these points, making the journey significantly shorter. But here's the catch. The existence of wormholes is purely theoretical, and even if they do exist, they present their own set of challenges. According to current understanding, wormholes would be extremely unstable, collapsing the moment anything tries to pass through. And to keep them open, that would require a form of matter with negative energy density, something we've yet to discover. Plus, there's the issue of navigation. Even if we could stabilize a wormhole, we don't yet have the means to control where it leads. It could open up to a distant galaxy, or it could lead straight into a black hole. It's a cosmic lottery with the odds not necessarily in our favor. So while wormholes are fascinating, we're not packing our bags for a wormhole journey just yet. With the current state of our knowledge and technology, the path to interstellar travel remains a challenging quest, but one that continues to inspire us to reach for the stars. So if we can't exceed light speed or reliably use wormholes, what other options do we have? Well, two intriguing possibilities are antimatter propulsion and light sails. Let's start with antimatter. In the world of particle physics, for every particle, there exists an antiparticle. When a particle and its antiparticle meet, they annihilate each other, releasing energy in the process. This energy, in theory, could be harnessed for propulsion. Imagine a spacecraft powered by an engine that uses antimatter. Such an engine could potentially reach a significant fraction of light speed. The energy produced by the annihilation of just 1 gram of antimatter with 1 gram of matter is roughly equivalent to the energy of 3 atomic bombs. The potential for high-speed space travel is immense. But there's a catch. Antimatter is incredibly difficult to produce and even more challenging to store. As of now, we can only produce a few nanograms per year, and we're still figuring out how to store it safely. Now, let's turn our attention to light sails. This concept is a bit more tangible. Think of a sailboat, but instead of wind, it's powered by light. Light, despite having no mass, carries momentum. So a sufficiently large and reflective sail could, in theory, be propelled by the pressure of sunlight or a powerful laser. In fact, this idea is already being tested. Projects like Breakthrough Starshot aim to send tiny, gram-scale spacecraft to our nearest stellar neighbor, Proxima Centauri, using a laser-powered light sail. If successful, these tiny spacecraft could reach speeds up to 20% the speed of light, getting them to Proxima Centauri in just over 20 years. These technologies are still in the realm of theory and speculation, but they show promise. Yes, there are massive hurdles to overcome, but if history has shown us anything, it's that human ingenuity knows no bounds. And who knows? One day, we might just find ourselves sailing on light or riding an antimatter engine to the stars. The prospect of interstellar travel is both tantalizing and daunting. As we've explored throughout this discussion, the concept of traveling to other star systems presents a host of challenges and possibilities. The sheer vastness of space is the first hurdle to overcome. With the closest star system, Alpha Centauri, over 4 light-years away, even reaching our nearest neighbor is an unimaginably vast endeavor. This distance, measured in the time it takes light to travel, is so immense that it's akin to trying to cross the entire Atlantic Ocean with only a single paddle. Our next challenge is the speed of light itself. Even if we could achieve light-speed travel, a concept that currently resides in the realm of science fiction, it would still take us 4 years to reach Alpha Centauri. And that's without considering the effects of time dilation, where time for the traveler slows down relative to the stationary observer. A journey that feels like a few years to the travelers could span decades or even centuries for those left behind on Earth. And then there are wormholes, theoretical shortcuts through the fabric of space-time. If they exist and if we could harness them, they could potentially allow us to leapfrog across the universe in the blink of an eye. But again, this is purely theoretical and fraught with its own set of challenges. In the face of these hurdles, we've proposed potential technologies like antimatter propulsion and light sails. Antimatter, when combined with regular matter, releases energy in a process that could theoretically propel a spacecraft at near light speed. Light sails, on the other hand, use the momentum of photons to propel a craft through space. Both technologies are theoretically possible, but practically implementing them presents a whole new set of challenges. So, while we may not be ready to visit other star systems yet, the journey of 1,000 light-years begins with a single theory: